An overcrowded electrical box presents a significant safety concern due to the increased risk of overheating and potential electrical fires. Identifying such a situation requires careful observation and an understanding of electrical codes and best practices. Firstly, visually inspect the electrical box. Look for signs of excessive wire fill where the box appears to be packed tightly with wires and connectors. Wires may be difficult to manage and may be bent or compressed excessively. Secondly, count the number of conductors within the box. This is a crucial step in determining if the box meets the fill requirements specified in the National Electrical Code, or NEC. The NEC provides specific guidelines for the maximum number of conductors allowed in a box of a given size. To accurately determine if an electrical box is overcrowded, you need to calculate the box fill. This involves assigning a volume allowance to each conductor, device, and fitting present in the box. The NEC specifies these volume allowances in cubic inches. Here's a breakdown of how to calculate box fill. Firstly, conductor fill. Each current carrying conductor and each grounding conductor counts towards the box fill. Each conductor is counted as one volume allowance based on its size. For example, a number 14 American wire gauge or AUG conductor has a smaller volume allowance than a number 12 AWG conductor. Secondly, device fill. Devices such as switches, receptacles, and fixture studs also contribute to the box fill. Each device counts as two conductor equivalents based on the largest conductor entering the box. For example, if the largest conductor in the box is number 12 AWG, each device counts as two number 12 AWG conductors. Thirdly, clamp fill. Internal cable clamps, if present, are counted as one conductor equivalent based on the largest conductor entering the box. If the box contains one or more internal cable clamps, you must include this in your calculation. Fourthly, equipment grounding conductor fill. All equipment grounding conductors entering the box are counted together as a single conductor equivalent, based on the largest equipment grounding conductor. This is a simplified approach compared to counting each one individually. Fifthly, fixture stud fill. A fixture stud or hickey counts as one conductor, based on the largest conductor entering the box. Sixthly, conductor volume allowances. The NEC provides tables that specify the volume allowance for conductors of different sizes. These tables are typically found in Article 314.16 of the NEC. You will need to consult these tables to determine the correct volume allowance for each conductor in the box. Seventhly, calculating total box fill. Once you have determined the volume allowance for each component, add them all together to obtain the total box fill. Eighthly, determining maximum box volume. The electrical box itself is marked with its cubic inch capacity. This marking is usually found on the inside of the box. Compare the total box fill you calculated with the box's marked capacity. Ninthly, assessing overcrowding. If the total box fill exceeds the box's capacity, the box is considered overcrowded. This is a violation of the NEC and must be corrected. Tenthly, corrective actions. If an electrical box is found to be overcrowded, several corrective actions can be taken. These include, firstly, replacing the box with a larger one that has sufficient capacity to accommodate all the conductors, devices, and fittings. Secondly, reducing the number of conductors in the box by rerouting some circuits to other boxes, where feasible. Thirdly, using more compact wiring methods, such as reducing the number of splices in the box. Fourthly, ensuring that all connections are properly made and that no wires are damaged or pinched. It is essential to consult the NEC and local electrical codes for specific requirements and to ensure that all work is performed by a qualified electrician. Addressing an overcrowded electrical box is not just about compliance with regulations, it is about ensuring the safety of the electrical system and preventing potential hazards. An overcrowded electrical box can lead to several problems, including firstly, overheating. When too many wires are packed into a small space, it restricts airflow and can cause the wires to overheat. Overheating can damage the insulation and the wires, leading to short circuits and electrical fires. Secondly, damaged insulation. The tight confines of an overcrowded box can cause the insulation on the wires to become damaged or brittle. This can expose the conductors and increase the risk of electrical shock. Thirdly, loose connections. Overcrowding can make it difficult to properly tighten wire connectors. Loose connections can cause arcing, which is a dangerous electrical discharge that can ignite flammable materials. Fourthly, difficulty in troubleshooting an overcrowded box makes it difficult to trace wires and troubleshoot electrical problems. This can lead to delays in identifying and resolving issues, potentially prolonging the hazard. Fifthly, code violations. An overcrowded electrical box is a violation of the NEC and local electrical codes. This can result in fines and other penalties. When evaluating an electrical box, it's important to consider several factors beyond just the number of wires. These factors can also contribute to overcrowding and potential hazards. Firstly, wire gauge. Different wire gauges have different volume allowances, as specified by the NEC. Larger gauge wires require more space than smaller gauge wires. Be sure to use the correct volume allowance for each wire size in your calculation. Secondly, number of splices. Splices take up space in the box. Minimize the number of splices whenever possible to reduce clutter and overcrowding. Consider using alternative wiring methods that require fewer splices. Thirdly, device types. Different types of devices, such as switches, receptacles, and dimmers, have different volume allowances. Be sure to use the correct volume allowance for each device type in your calculation. Fourthly, box material. The material of the electrical box can also affect its capacity. Metal boxes typically have a larger capacity than plastic boxes. Consider using metal boxes in situations where overcrowding is a concern. Fifthly, box shape. The shape of the electrical box can also affect its capacity. Rectangular boxes typically have a larger capacity than square boxes. Consider using rectangular boxes in situations where overcrowding is a concern. The NEC provides specific guidelines for the installation of electrical boxes. These guidelines are designed to prevent overcrowding and ensure the safety of the electrical system. Article 314.16 of the NEC covers box fill calculations and provides tables that specify the maximum number of conductors allowed in boxes of different sizes. Article 314.17 covers box fill requirements for boxes containing devices, such as switches and receptacles. Article 314.20 covers box fill requirements for boxes containing splices and terminations. Article 314.27 covers box fill requirements for boxes containing lighting fixtures. When performing electrical work, it is essential to follow the NEC and local electrical codes. These codes are designed to protect people and property from electrical hazards. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. In addition to following the NEC, there are several best practices that can help prevent electrical box overcrowding. Firstly, plan ahead before starting any electrical work. Take the time to plan the wiring layout and determine the appropriate size electrical boxes. This will help you avoid overcrowding later on. Secondly, use larger boxes when in doubt. If you are unsure whether a particular box will be large enough, it is always better to err on the side of caution and use a larger box. Thirdly, minimize splices. Use alternative wiring methods that require fewer splices. This will reduce clutter and overcrowding in the box. Fourthly, use compact devices. Choose devices that are designed to take up less space in the box. This can help you fit more devices into a smaller box. Fifthly, label wires. Clearly label all wires in the box. This will make it easier to troubleshoot electrical problems later on. Addressing an overcrowded electrical box is a critical step in ensuring electrical safety. By following the NEC, local electrical codes, and best practices, you can prevent overcrowding and create a safe and reliable electrical system. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical safety. Electrical work can be dangerous, and it is always best to leave it to the professionals. Proper inspection and correction are essential components of maintaining a safe electrical system. It is very important to note that this information is general and the National Electrical Code, or NEC, and local code should be consulted for specific requirements. A qualified electrician should perform any electrical work. Understanding box fill calculations is paramount in ensuring electrical safety. By adhering to NEC guidelines and utilizing appropriate box sizes, electrical professionals can prevent hazardous situations and maintain code compliance. Firstly, calculate conductor fill. Determine the volume allowance for each conductor based on its size as per NEC tables. Secondly, account for devices. Devices like switches and receptacles are counted as two conductor equivalents. Thirdly, include clamps. Internal cable clamps are counted as one conductor equivalent. Fourthly, consider equipment grounding conductors. Equipment grounding conductors are counted as a single conductor equivalent. Fifthly, determine maximum box volume. The electrical box is marked with its cubic inch capacity, which must not be exceeded. Sixthly, assess overcrowding. If the total box fill exceeds the box capacity, the box is overcrowded and needs correction. To further elaborate, let's consider how different types of conductors contribute to the overall box fill calculation. Firstly, current carrying conductors. These are the conductors that carry the electrical current to devices and appliances. Each current carrying conductor contributes to the box fill based on its size. For example, a number 14 AWG conductor will have a smaller volume allowance compared to a number 12 AWG conductor. Secondly, neutral conductors. Neutral conductors are also considered current carrying conductors and must be included in the box fill calculation. The NEC requires that neutral conductors be counted the same as phase conductors. Thirdly, equipment grounding conductors. These conductors provide a path for fault current to return to the source, helping to protect against electrical shock. All equipment grounding conductors entering the box are counted together as a single conductor equivalent. Fourthly, bonding jumpers. Bonding jumpers are used to connect metal parts of the electrical system together, ensuring that they are all at the same electrical potential. Bonding jumpers are typically included in the equipment grounding conductor count. Fifthly, control circuit conductors. In some cases, electrical boxes may contain control circuit conductors which are used to control various electrical devices or systems. Control circuit conductors must also be included in the box fill calculation. It's important to note that the specific requirements for box fill calculations can vary depending on the type of electrical system and the local electrical codes. Therefore, it's always best to consult with a qualified electrician or electrical inspector to ensure that you are following the correct procedures. In addition to the conductor fill, device fill, and clamp fill calculations, there are also other factors that can affect the amount of space available in an electrical box. Firstly, the size and shape of the box can impact the amount of usable space. Deeper boxes and rectangular boxes generally provide more space than shallow boxes and square boxes. Secondly, the location of the box can also be a factor. Boxes that are located in hard-to-reach areas may be more difficult to work in, and it may be necessary to use a larger box to provide more space. Thirdly, the presence of other equipment or components in the box can also reduce the amount of available space. For example, if the box contains a transformer or other bulky equipment, it may be necessary to use a larger box. To ensure that an electrical box is not overcrowded, it's important to carefully plan the wiring layout and select the appropriate size and type of box. It's also important to use the correct wiring methods and to avoid unnecessary splices or connections in the box. Finally, it's essential to inspect the box regularly to ensure that it remains in good condition and that there are no signs of overcrowding. If you notice any signs of overcrowding, it's important to take corrective action immediately to prevent potential electrical hazards. This may involve replacing the box with a larger one, rerouting some of the wiring, or removing unnecessary components from the box. Remember, electrical safety is paramount, and it's always best to err on the side of caution when dealing with electrical systems. Consulting with a qualified electrician or electrical inspector can help you ensure that your electrical system is safe and code compliant. Lastly, consider wire management techniques to optimize space utilization within electrical boxes. Firstly, use wire connectors that minimize bulk. Secondly, neatly arrange wires within the box. Thirdly, avoid excessive wire slack. Fourthly, bundle and secure wires properly. These practices enhance safety and accessibility for future maintenance. By implementing these strategies, professionals can effectively manage wire congestion and mitigate the risks associated with overcrowded electrical boxes, promoting safer and more reliable electrical installations.